Thanks everyone for coming. My name is Kyle, and thanks for coming to this session on building greener software. So I decided to put this talk together about 2 years ago, after I became vegan after watching a bunch of documentaries on animal agriculture and the environment. And that's kind of where my passion for this sort of subject stemmed from. I've been looking into a lot of things to do with the environment and sustainability since then. And that's kind of what prompted me to talk a bit more about this in public. So a little bit more about Made-Tech before I start. Made-Tech are a public sector consultancy helping organizations to modernize, accelerate, drive, and enable them to build more cloud-friendly and modern architectures. So before we can start to have an idea of how we can reduce our impact, we should probably have a look at the impact we're currently having through the design of our software. So for the first section, I'm going to look at the resources we use when we're designing services, engineering components, deploying them to a particular platform, and then hosting them in the long term. So as you may have already guessed, the main resource we all use day-to-day is electricity. Global data centers use between 1% and 3% of all electricity provision through year across the globe. To put that into a bit of a better number, is around about 416 terawatt hours generated in 2015 went towards data centers. On average, the UK as a whole only uses around 300 terawatt hours. So as you can see, this is quite a large number in comparison. The problem with this is that the majority of energy is not generated through renewable technologies. As it currently stands, around 47% of the UK's energy production was in 2020 was through renewables, and even including things like biomass and nuclear, and those numbers only brought up to around 60%. 2020 was classed as a record-breaking year for renewable production in the UK, and it still only came to around about 181 grams of CO2 per kilowatt hour. So there's still a long way to go for that. To put it into a bit more perspective, the average solar panel in England generates around 3,000 kilowatt hours per year in ideal conditions. And the average wind turbine generates around 6 gigawatt hours per year. So in order to produce the 416 terawatt hours used by data centers around the world, 146 million solar panels or 69,000 wind turbines would be needed. To put that into perspective again, around about 1 billion people still have no access to electricity, according to Habitat for Humanity. The other we use quite a lot of is water. The average data center in the US uses 626 billion gallons of water annually. And Google data centers use around about 1.5 million gallons for a single data center. For a bit of a comparison, 1 gallon is about 16 glasses of water, and the average household uses about 76 gallons of water in a single day. The water is generally used as a coolant to cool hardware in order to reduce the temperature of the air, which is then used to cool the hardware. And a medium-sized data center generally uses around about the same amount as 3 hospitals or 8 households. A large portion of the world still has no access to clean running water. So again, this is a bit of a travesty in that side as well. So now that we're a bit more aware of the resources being used by the data centers, it's time to ask the question, how can engineers build greener services? So we can start to take a look at the actions we can take to mitigate our impact, and I'll split these into 2 categories: fairly high level technical improvements and actions for non-technical teams to take away as well. So the most important one is to migrate to cloud-hosted infrastructure. When I'm speaking about this, I'm generally speaking about the public cloud infrastructure, but at the moment, 12 to 18% of on-premises servers is the utilization used there, whereas in the cloud it's around about 65% on average. So it's a significant improvement across the board from that side. Cloud consumers use around about 77% fewer servers due to this, and it means that it reduces the carbon footprint by about 88% overall. By 2022, it's estimated that around about 33% of enterprise infrastructure will be hosted on premises, which it means that there's still quite a bit to go. You can also compare cloud providers, as there's no right or wrong answer, but there are additional factors to consider as well to do with the business case. So some of the questions we can ask ourselves are, is the provider investing in clean energy? Is the provider offsetting their carbon footprint? Does the provider provide carbon footprint metrics? And is the provider researching new ways to reduce the impact even further? So there are some answers available to these questions online. Most of the major cloud providers, such as Amazon and things, do invest in clean energy, partly because it's in line with their own ESG goals, but also to reduce their running costs and allow them to price more competitively. AWS, Microsoft, and Google all publicly state they offset their carbon footprint, but none of them mention how much by. And Google is the only one to publish carbon footprint metrics for each data center, which is updated multiple times a day. Microsoft allows some carbon metrics to be extracted from Azure using Power BI extensions, but AWS only publishes them in company statements and things like that, so they're a bit harder to find. AWS and Microsoft are both researching new measures to reduce their resource use. AWS is using reclaimed water for their cooling, and Azure is pioneering liquid immersion cooling in their data centers. So they're both having their own methods to do in reducing the resources they're using. You can also adopt a serverless architecture, which means that you use managed infrastructure with a pay-as-you-go pricing, mostly shared hardware, and high scalability and elasticity. This means that engineers have more time to work on solving business problems, encourages high utilization through the pricing strategy and through the multi-tenancy options. And the pricing strategy means that any money saved can be put towards other actions, such as offsetting emissions. Using shared hardware from multi-tenancy options means that 35% utilization being wasted by the average customer can then be pooled to be leveraged by other customers. And the high scalability and elasticity allows an easy increase or decrease based on usage factors. It's currently estimated that around about 40% of organizations have adopted serverless architectures, so there's still quite a long way to go there. We can also follow best practices. So I've split these into cloud best practices and general hints and tips to do with your software itself. So the main example that I can find is the well-architected framework, which is the best practices for design, delivery, and maintenance of cloud architectures. It follows 5 key pillars, including security, reliability, performance efficiency, operational excellence, and cost optimization. So the further down this list we go, the more they are kind of aimed at the environmental side of things as well, and efficiency. And they help the environment by preventing idling and wasteful processes. So these days, the website is the face of brand, and quite a lot of the time, this seems to be all singing and all dancing these days. So it's a good thing to optimize there wherever you can. I've included a bunch of examples here of possible ways you can reduce your impact by making your website a bit more efficient. One I'm going to draw attention to in particular is blocking bots and web scrapers. I previously worked in a startup that did quite a lot of web scraping, and the measures that go into stopping these actions are quite minimal. On the flip side, they do kind of make your website a bit more inefficient, and it does take a bit more electricity by running those services on them. So increasing the visibility of your impact. So this is where I'm going to go into a bit more of the open source side of things. There are various tools and metrics available to help monitor your carbon footprint. Some here includes the Green Web Foundation and Whole Grain Digital. They're more on monitoring your website itself. One looks at how green the host is, whereas the other kind of looks at how optimized the actual website's functionality is. There's this Python package called Code Carbon, which basically works as kind of like a stopwatch, and it goes through outputs a bunch of metrics to do with the energy mix for the locale, how long the piece of code took to run, and this, that, and the other, so that it gives you a bunch of metrics associated with the energy use and the carbon footprint of that energy. And the last three on this list are all to help you a bit more on which data centers are powered by green energy or renewables. So pulling it across to the Cloud Sustainability Console by Paul Johnston. It's an open source package which basically just highlights AWS regions that are confirmed to be running on 100% renewable energy. So now that I've finished talking about the technical side of things, I'll go a bit more into the side of the actions that non-technical teams can do behind the scenes. So when I'm talking about non-technical teams, I'm thinking of marketing, HR, finance teams, all those sort of things. Each department has their own processes that contribute and influence the overall footprint of the company. So it's important to mention these two. So documentation and processes is a bit on the dull side, but there are a bunch of things you can do on this sort of side of things. There are monitoring assessments you can undertake. I've mentioned the sustainability calculator and Code Carbon in previous slides. There's also the EcoVadis platform, which is a platform that measures your organization's social responsibility. It's used by around about 75,000 companies, I think it was the last I checked, and it's used in over 160 countries, so it's pretty well known. Environment and sustainability policies, it sets out the kind of visions, expectations for the company as a whole, and kind of gives you a bit of a baseline. And then there's also the certifications as well, but which I've listed. Each of these headings kind of flow into each other, so it's best to kind of start at the top, just because a lot of the certifications generally ask for things like monitoring and assessments. So empowering climate-friendly choices for the staff as well is a pretty big one. One of the most important is the employment benefits. So there's ethical pension funds, climate-friendly travel, and I've listed a couple of options for that. There's also plant-based food and drink options and providing recycling bins in offices. They all seem fairly simple, but when you take into account that in 2019, it was estimated that around about 50 trillion was invested through pensions alone, and Morgan Stanley estimated around about the same amount was required to meet the Paris Agreement. The first figure was given by the OECD. So it's quite staggering that the same amount is for both. The problem at the moment is the majority of it is invested in environmentally damaging industries like fossil fuels. So just switching a pension is quite an important thing to do as well. I'll draw attention as well to the plant-based food and drink options. The average diet takes between 2.5 and 3.5 tons of CO2 per day. The average plant-based diet, on the other hand, takes around 1.5 tons. So even just implementing things like meatless Mondays or veganuary can have a huge effect on your overall footprint. And the previous slides have all kind of focused on reducing your impact, whereas this slide I've kind of put into look at where you can reuse and how we can reuse. So you can remove single-use items from the office spaces. You can put in place resource sharing and trading channels. And you can also purchase supplies from more sustainable sources. So the middle one is what I'm going to draw attention to a bit more here. The idea was kind of inspired by a bunch of WhatsApp groups and things I've seen locally where people are asking if somebody else could make use of something before disposing. So it's kind of fosters that sense of community. But then we thought about using that a bit more as an organization, and it makes sense to use things like learning budgets and things where you normally buy a book. You just see if anybody else in the company's got the same book and just share it amongst yourselves. It makes the learning budgets go a bit further and also reduces things like packaging and all that sort of things. And here's some key takeaways from the slides. A lot of them are just things I've mentioned in previous slides. So 1 to 3% of all electricity is used by data centers, and over 600 billion gallons of water are used by data centers annually in the US alone. And then some solutions to those are migrating to the cloud, reducing your climate footprint by up to 88%, choosing serverless and best practices resulting in less wastage, and then increasing visibility of your carbon footprint, which helps promote environmentally friendly choices.